Great. So let's get it started. I hope you enjoyed the conference so far, and thanks for coming to my session. And today we're going to talk about natural language processing in feedback analysis. Natural language processing, we know it's not something new, right? It's been there for a few decades. However, with recent progress, there has been some significant improvements, especially with the help of the neural network. And today, we'll go through some of the popular neural network models and see how can we leverage them in feedback analysis, and especially how can we leverage them to extract more detailed insights from the feedbacks. And so the agenda for today, before we go into the models, let's first talk about some of the backgrounds. Why do we need NLP for feedback analysis? Right? There are other ways to do that, and that's not the only way. And after that, we'll talk about how can we solve two of the major problems for feedback analysis. So first one is that what are people talking about in the feedback? And after that, for the things people are talking about, how do they feel about them? And we will look at the neural network models and see how can we leverage them to solve these two problems. And we will summarize and talk about what we learned from this approach. Great, let's come to the first one. Okay, why do we need NLP for feedback analysis? So if you are a business owner, right, there are really four main things that you need to care about. So you want to make sure that your customers are happy, and you want to make sure your employees are engaged. And you want to make wise investments on your branding, and you want to build the right features for your product. And at Qualtrics, and by the way, I'm an engineering manager at Qualtrics, and my team works on text analytics, and this is exactly the things that we are working on. And at Qualtrics, we are providing a platform, a solution for our clients to collect, analyze, and act on the feedbacks so that they can, within a single platform, a single solution, be able to manage all four areas of these important experiences. So to better illustrate our challenge here today, let me take another role. Right? Let's assume that I'm also now a hotel manager, and let's see what are the challenges that I'm going to face as a hotel manager, and that could help us better understand what are the challenges that we need to solve. Okay, as a hotel manager, I want to make sure that my hotels is healthy and running good, right? I want to collect feedback from my clients. And one major way for that is through the surveys. And this is a typical question you will see, right? On the scale of 0 to 10, how likely are you to recommend, in this case, my fancy hotel, as you see, to my friend, to your friend, sorry. And it would be great that I can get high ratings like 9s or 10s in this question, but that may not always be the case. Sometimes I may get 5s, or sometimes I may get 0s. And this question can give me a pretty good overview of how am I doing. But I would like to know more, right? That's going to be helpful. What am I doing good, and how can I improve further? And for that, one way to do that is that I add more questions to this array, and I iterate through all the aspects that I care about and add more multiple choice questions. And this is only part of the survey. The survey could be much longer than this. And it's going to take much longer for my customers to fill this survey. It's not going to be a good experience for them, and they may drop out halfway. And that's also going to be very bad for me because I don't get valuable feedbacks from them. What if we can do it in a different way, right? What if we can just ask a single question after the score question? We can ask why, right? Please tell me why am I getting this score, and what am I doing good, and how can I improve? And this way, it's going to be a much shorter survey. It's better for my customers, and I can get more detailed feedbacks. Rather than a score, I can get what is the details on each aspect am I doing, and I can even get feedbacks on the things I'm not expecting. Okay, so this is great, and let's say I send this to my customers and I got some feedback, and here are some of the sample feedbacks. And for sure, I don't own this survey. I don't own this hotel, so these are not real survey results. And I got some public available hotel reviews here, and we will use them through this session. Okay, if we read through them, okay, first one, I know I got positive feedback on location, and staff were really friendly. That's great. And second one, check-in experience is good, and kitchen is fully equipped. That's nice. And third one, amenities were good. However, I got feedback on housekeeping. Okay, that's helpful, and I will follow up on that and improve my overall experience on that. Okay, after this, what's next? So we got 3 of them reviewed, and I see there's still 20,000 more to go. That's just going to be way too much, and it's really a lot. There's no way I can get them processed myself. So with this, it's really nice if we can automatically analyze all the feedbacks and get a result and get an overview on, first, what are people talking about in the feedback set? And secondly, for the things they are talking about, how do they feel about them? And with this, I can follow up, I can prioritize, I can know where should I spend my budget on to better improve my overall business and experience. And these are the key questions that my team at Qualtrics is working on, and is a majority part of our responsibility. And let's take a look on how can we approach to each of them. Okay, first one, what are people talking about in the feedback? To be able to answer this question, we first need to know that what exactly are we expecting from this question, right? Because that's kind of relatively vague. Okay, first thing we are expecting, right? As we see from the example of my fancy hotel, that there's going to be a lot of feedback, and it's likely that I won't be able to address all of them. So I need to know what are the top themes, top topics being talked about, so that I can prioritize them first. So for this question, the first goal is then that what are the top topics among all the comments? They could be talking about my staff, the hotel room, or check-in, check-out experience. And with that, remember, we still have another question, right? For the things they are talking about, we want to understand, okay, how do people feel about the things they are talking about? And with that, we want to be able to know what is the subset of all the comments that is talking about each of the topics. So what are the related topics for the comments? And with that, we want to figure out what are the keywords we can use to search for related comments for each of the topics. For example, if I want to find all the comments about my staff, my customers may not always use the word staff in the comments, right? They may use concierge, manager, or employees. So it would be great if we could, along with the topics, find out what are the keywords we can use to figure out what are the related comments, so that we can analyze these comments and get the details. Okay, now we understand the problem. What are the options we have on solving this problem? And it turned out this problem is very close to an NLP topic, which is topic modeling. And for topic modeling, it's similar. It's also about discovering the abstract topics for a collection of the documents. And each topic is also considered as a distribution over the words. And that's great. We got a very similar problem. And okay, how can we solve topic modeling? And we search around, And luckily, there's a dominant approach for topic modeling named LDA. If you check the major cloud vendors, machine learning platform vendors, and there will be use cases like this. And that's even better. We got a similar problem, and we got a dominant solution for that. And that's promising. Let's run it through our hotel reviews. But it turned out, however we try to tune around, the result that just doesn't seem to be working well for our questions. And the major problem we see is the coherence issue of the topics. We often see unrelated words that appear in the same topic. And here are just 3 of the examples that come from the output of the LDA model. Okay, that could be an issue because remember, for this question, what we want to do is that we want to identify the top themes. We want to have the topic to have a clear semantic meaning there. And if the topic contains unrelated words, then we cannot clearly identify a topic, and not to mention use these words to search for related comments. But this is a very promising model. It's a dominant approach. We want to know why. So we looked into it. So in high-level, LDA works this way. So you assume there's a group of topics on the left side. You can see that. And each topic is a distribution over words. And you consider each document to be a distribution over topics. And the documents are actually generated this way. So for each word in the document, it will first, based on the distribution, select a topic, and based on the word distribution, select a word. And you repeat this for all the words in the document so that it regenerates the document. And with that, the training process will align the distribution with the documents used in the training, and that's how LDA generates these topics. And from this, you can see there are mainly 2 problems. One is that the words they're actually generated independently. So they are not considering the co-occurrence of the words within the same document or sentence. And if you think about how we speak a language, that's not really what we do, right? The words we use is strongly correlated with the context words around it. And missing this in the model, missing the co-occurrence, and that could be a major reason that why we can see unrelated words in the topic. So another assumption that this model has is that the documents, the articles, they are distribution over the topics. And for longer articles, that may work well, but if you look at the feedbacks, they are usually quite short. They are just a few sentences. And with that, it's going to be harder to estimate the distributions of the topics over each of them, and not to mention we will have a lot of them. Okay, with this too, we know, unfortunately for this most popular approach for topic modeling, we have these fundamental problems, and without a major refactor, we won't be able to use them. Okay, what are the alternative approaches? So we thought about search. So this is an information retrieval process, right? So search is very popular. For search, you got a keyword, and you got a set of documents. You try to find the most representative documents for these words. What if we can do it in another way? Right? We have a set of documents, and we are trying to find the most representative words for this document. Then we can use the word frequency, because if the words appear more often in this document, then it's likely to be more representative. And we also normalize it, because some words just appear more often in English than others. So we divide the word frequency by the word frequency of the corresponding word in overall English, and we normalize it. And of course, we did some other cleanups, like removing the stop words, and did some lemmatization. And here are some of the top representative words we got for the reviews. And you see there's concierge, there's pool, there's booking. It's about the important aspects regarding a hotel operation. So that's helpful, but they are not topics, right? Because we cannot just use these words to locate related comments. Okay, then what can we do to extend them and find the related words so that we can have topics there? So this is the model that can help. So word2vec is a very popular model recently in NLP, and is one of the major breakthroughs in the past few years. And from its name, you can see it's word2vec, so it's converting words to vectors. And the goal is to represent words in vectors so that the semantic relationship between the words are now represented by the vectors. And you can see that's a really, really challenging goal, right? So the model must be very complex, and it turned out it's actually not. So for the input of this model, it just has one assumption that it's actually a typical English article or documents got fed into the model. There's no special processing required, and there's no special labeling required. And with that, you can feed in a lot of data into the model, and you can easily find this data through news, books, articles. And later, we'll actually see some examples from a model that's trained with 100 billion words of Google News articles. Okay, that's the input. What about the model? The model is actually also very simple. It's a simple structured neural network. And the training goal is to learn about the context of each of the words in all the articles. And the context, we mean that what are the words usually appear around this word in English articles. Okay, the model tries to learn this, and the output of the model is then in this case, is then all the words that appeared in the articles, and each is now assigned with a vector. And those vectors, they look like this. They are high dimension vectors with fixed dimensionality, and a popular used dimensionality is 300. And each dimension is actually a floating number there. And so what does each of the dimension mean? And unfortunately, it doesn't have a clear meaning. So let's see how the semantic relationships are represented in these vectors. Okay, so the directions in the vector space actually throughout this training process are specialized toward the semantic relationships between words. And here are some of the examples. And in the first one, you can see is a male to female relationship. And in the visualization, you can see there's a king to queen, and there's man to woman. And you can see the direction from the male word to the female word are very similar between these two pairs of words. And same thing for the verb tenses. We have walking to walk and swimming to swim. And for the country to capital relationship on the right side, and left side is, in this visualization, left side is the country names, and right side is the capital. And you can see the directions are very similar. And this is very interesting is because, as you can see, the models or the input data doesn't have any knowledge or direct knowledge or assumption over these semantic relationships. And somehow, through the training process, the model is able to get this into the vector space. And with that, it's not limited to these three. And actually, a lot of relationship can be caught in this process. And okay, that's interesting. And another thing with this model is that the semantic relationship actually kind of cluster together in the vector space. If you look at the training goal of this model, right, it's trying to learn about the context of each word. Then if words are used in similar contexts, in similar articles, talking about similar things, they are more likely to get very similar vectors. And with that, they are more likely to cluster together in the vector space. And here are some of the examples from the 100 billion Google News article model. The visualization for hotel, you can see around hotel, there are words used in similar contexts like Vegas, room, or residence. On the right side, if you look at the word pool, it has swimming, tournament, sports, Olympic. And these are some of the contexts that got embedded into this vector space, and we see this semantic clustering. Okay, coming back to our problem, right? We have the top representative words. Okay, can we leverage something similar to extend them to a group of words that are talking about the same topic? So we get back to the representative words, and we run all the feedbacks we got through the word-to-vec model. And with that, we got vector for each of them, and we got the nearest neighbor in this case around each of the representative words. Okay, here's what we got. And you can see we do get similar words that are talking about the same topics. For concierge, we know there's personnel, there's receptionist, there's employees. And we also get some other things. For example, the typos of words. If you look at the topic Q, and you can see there's all kinds of misspelled word Q in this topic, and we can actually use them to locate related comments. Okay, that's good, and this looks promising, and how can we further improve? And remember, we talked about the coherence of the topic. Right, let's take an example. We have a topic for pool, and it has these words. And it's better because now this pool topic, we see there's jacuzzi, there's lifeguard, and there's deck, and it's more about the pool in the hotel rather than the pool in the Olympic Games. And that's great, but somehow it also has a word redo or marble. Maybe in my hotel I'm remodeling the pool section. But it's not always be the case that these kind of words could always locate comments that are talking about pool. So there's a bit of overfitting here. And that's especially a bigger problem if your like response set or your feedbacks are like the set is small. And now we see there's a problem of directly using the Google News model that is going to be too generic, and this one could be too specific. And we actually went through a process to combine them together so that we can locate somewhere in the middle. And secondly, we see words like code. And these adjectives, they are generally very broad, and it's not helpful for us to locate related comments. So we run the comments through the part of speech tagging, and we know the type of each word and remove the types that we don't want. And third, so this is a topic about pool, and for that we know that words like swimming pool, hot tub, they are very related and they have significant semantic meaning, and somehow that's currently missed in the model. And we made a change to model to include these phrases also. Okay. Now we talked about how can we improve on coherence. What about topic distribution? Right, as we talked about, we are getting the top representative words from the feedback set, but they may talk about very similar things. Here are some of the examples on the left side. So we see there's towel, shower, toilet, bathrobe. They're all talking about the bathroom. And this is not really helpful, and how can we improve? So we read around, and there's a research actually on this especially, and it's actually doing it in a very similar way of how people do machine translation. Right? It first translated this set of responses, this set of feedbacks, to a set of topics, and then you translate it back in the same way. And the goal of this training process is to have the topics to be as representative to the feedback set as much as possible. And during this process, these topics will actually spread out, and they are more evenly distributed so that it can serve for the training goal of representing the overall feedback set. And after that, we only got one topic regarding the bathroom, and we got other things on the hotel room, like bedding or kitchen or smell. And great, so we talked about quite some improvements. Now we know there's another way to get the topics, and we have better coherence, we have better distribution. Let's take a look at the result. So now we know that for my fancy hotel, the top talked about topics in the feedback from my clients are staff, breakfast, and bathroom. And it's also talking about other aspects regarding the service, the facility, or the hotel room, like booking, bedding, or hallway, or smell, or swimming pool. And for the topics here, and down there you see some sample topics. We can see we also got more semantically related words for these topics. And for staff, we got manager, employee, receptionists. And bathroom, we got soap, shampoo, towel, and conditioner. And that's great. So in this way, we kind of have a way to automatically run through the comments and bring our clients some ideas to the question that what are people talking about. And let's move to the second one. Okay, how do people feel about it? And for this question, a pretty close problem is then going to be sentiment analysis. For the comments we got regarding my fancy hotel, okay, whether that's negative or neutral or positive, let's look at some examples here. So first one, staff side pool are very rude. And we see this, we see the word rude, and we know that's negative. And second one, we see beautiful and good view, we know that's positive. And same for the third one, we see not good. The good is possible, but there's a negation logic in front of it, so it's negative. And that brings us one idea, right? What if we can do this way, right? We label all the semantic words to form the semantic lexicon, and we also code the rules that could change the sentiment of this lexicon. And then we process the comments through the algorithm and match with the lexicon, and we got the result. So that's actually the lexicon-based sentiment analysis. But there are challenges with this. For example, this one, right? For the sentiment word cheap, if we see it in the context that it is cheap, then it could be talking about price, right? That's a good thing. But if it's talking about it looks cheap, then that's related to the quality of the product, then that's pretty negative. And for the second one, we see random items were stepped on when walking on the pool floor. We know that's pretty bad, that's pretty negative, but there's not really a sentiment word in it, and it's really hard to make a rule for that. Okay, what if we can find a way to save us the effort on labeling the sentiment words and also avoid coding the related rules? So we can do that with the neural network-based approach. And we rolled around, and it turned out there's several neural network models that are all able to do this task. And they actually perform very similar. And they all perform, like in Hello, the architecture looks similar. So you prepare your training data to be a pair of your comments and the sentiment label, and you train the neural network to feed for this training data, and then you run similar reviews, similar comments through it, and you got the result. And there's a convolution neural network-based approach on that, and there's a recurrent neural network-based approach on that to perform very similar. And okay, how should we choose? And let's first take a look at how they perform, or how they work. So convolutional neural network, in general, that's more of like a feature selection neural network. And here we have an example here. The staff at pool are very rude. And the first step there, you first take all the diagrams, as you see here, as the features, and iterate through the comments and get all the diagrams as potential features. And some models can also do trigrams or 4 words or 5 words. But in this example, let's use diagram. And after that, you run the diagrams with these word vectors through a convolution layer and get a numeric value, get a score for each of the feature. And as you can see here. And after that, it's a feature selection process. Based on these scores, the model will select the top representative feature for this input comments. And with that feature, you run through a classifier to get the sentiment label for this input. Okay, we see overall, this is a neural network where you put the comments as the input and the sentiment label as the output. And it's a feature selection process in between. And great, and this is very popular actually in computer vision because pattern recognition is a big part for that. And okay, this is one approach. Then what about the recurrent neural network? So recurrent neural network, it also takes the sentence as input and has the label as output. And it actually treats the input as a sequence of signals. So you will first take the first word, convert it into the word vector, and run it through the neural network and got a vector. We name it hidden state, which is kind of the edge here. And then it repeats itself, take the second word, run through the network again, this time along with the hidden vector for the previous step, and it repeats through all the words of these comments. So that's why it's named recurrent. And after it processing through all the words of the comment, and it got a hidden state that represents everything in this comment, and then that hidden state is run through a classifier, and we got a sentiment result. And there's actually a very popular extension of this, because as you can see, running through this process, it has to remember, or it has to process the next word all the time. And after a while, it will forget about the earlier things. And what if that's the most important thing for sentiment? And for this extension, it's named the long short-term memory network. And it has a longer, but still short-term memory. And with this extension, it has a memory cell in it, and it also has a forget logic in it. And with that, it can choose to remember or intentionally forget some of the words which the model thinks is not important or relevant to the task. And with that, okay, we got another way to process the sentiment task with neural network. And okay, this way, again, same type of input and output, and it's taking the comments as a sequence of signals. Okay, now how should we choose? We actually see the LSTM is more popular and has like higher performance. And should we go with the one with higher performance? But now we actually see our problem is actually a little bit different with what people are doing in the research, right? For the research papers, people are given a fixed problem and a fixed training set and fixed testing set. And the goal is to come up with a model to perform better under these specific constraints. But we are actually not limited to that. We have the ability to add more high-quality training data, find a way to collect more high-quality training data, and to improve the performance of the model. And with that, the scalability of the model is actually very important. We want to be able to train on more training data. And if you like to look at these two models, CNN is a feature selection process. Features are relatively independent to each other. And with that, it can be easily parallelized, and it performs much better on GPUs. And meanwhile, LSTM is treating the inputs as a sequence of signals, so it has to process one before another. So it's harder to parallelize, and it takes longer time to train. So with that, we actually go with the one that is more easy to scale. And this is the result that we got. So we see, on average, we see a 50% improvement on accuracy over the lexicon approach. And throughout this process, we learned that it's very important to keep your training data balanced across both the label and the domains, because this is the major thing that model is learning from. So it has no assumption, so this is very important. Okay, after this, we got a sentiment result for my hotel. And now I know, luckily for the most talked about thing, the breakfast and stuff, I'm actually performing really good, so that's nice. But there are some lowlights here. So for example, booking, bedding, and smell, these topics, we got lower rating. Okay, we know that we want to put more effort on this so that we can improve the overall experience of our customers. But does this answer the second question, how do people feel? It answers it to some extent, but that's not all of it. Right? There are some other things. For example, I know I'm not doing good on bedding, but why is that? Is that it's not comfortable or it's not clean? Right? Here, some related problems like opinion extraction could help. It can better tell us that what people think about the booking or bedding experience. And another interesting thing is for emotion analysis, because emotion is something really you should address differently. Right? Because, for example, if, let's say, my wife, she say she's not happy, right? What I need to do is really not like talk her through it and persuade that this is not something that you should feel unhappy about, and try to persuade her. Right? Instead, I should really do is do the things that make her happy, right? Buy gifts, buy flowers, and that's the way to address emotions. And similarly, for the customers, it could be similar. Right? We want to acknowledge the customer's feelings, and we want to react on it. So in this case, it would be really helpful if we could detect strong emotions from the comments also. And for these two problems, we won't go into the details on how to solve them, but they actually can be solved similarly with the neural networks we talk about. Because when we were talking about how to leverage these neural networks for sentiment, we actually see there's no special logic regarding sentiment. Right? The training data is just comments and the label. And these neural networks are really generic. So if we can somehow collect good quality training data for comments and emotion pairs and use it as a training data, this can solve the other problems, other similar classification problems. Okay, now we go through the models on how can we answer these two main questions for feedback analysis. And okay, what we learned from the process. So first thing, I want to mention that the field of NLP is really changing a lot. There's significant improvements with neural networks, and now people can do much more. For example, you can see there's much better machine translation or speech recognition available in the market, and there's a lot of AI speakers out there. And this field is very interesting. So if you're interested, I do encourage you to look around and read more about it. And somehow, for natural language processing, there is still a lot that we can improve, because the natural language is hard to process because you need to understand it and you need to be able to process the logic within it. And we said for many of the major problems out there, there is actually not a good enough solution that you can just directly use it for open domain use cases. So with that, what we learned from this process when we develop these models is that it's very important to understand both the machine learning models and your business problem so that you can come up with the right constraint. And this constraint can work for both your business problem and the model. And with this constraint, it makes your model easier to perform, and you can reach a very good quality performance and deliver it for your business use case. And we also see the models are becoming more and more generic, right? No special assumption on the input, and no hard labeling for the training data. And in this case, being able to collect high quality signal is very important for the performance of your model. And with that, you need to leverage the platform and build this into your use case and have the human-in-the-loop solution so that you are able to get this high-quality data and keep improving on the performance of your model. So with this, we conclude our talk today. And if you're interested in learning more about how we do this, or learning more about what are the other things that Qualtrics is doing that is very interesting, and please come and meet us at the Qualtrics booth. And thank you for coming to my session.